So again, in 5.3, we're going to be looking at solving systems of equations, and we're going to ask ourselves how we can use, what's the word right here? Elimination, okay? We've done so by graphing. We've done so by substitution. Today we're going to look at what it looks like to solve a system of equations by using elimination. So the question we want to ask is, how can you use elimination to solve systems of equations? So it looks like our goals for today are to solve systems of equations by, what are the two options they give you? Adding and subtracting. If you look back at this right here, wasn't I giving you a lot of adding and subtracting examples? And specifically a lot of adding and subtracting examples where what happened to each term? What do they do to each other? Cancel out. So we're going to look to try and cancel out a variable to go from 2 variables down to 1 variable. And then the second one, we'll use systems of linear equations to solve real life problems. I think you'll catch on quickly to this. All right, we need to establish some vocabulary here. Is there a line right here for you guys?
Yeah.
All right, let me put my horizontal in there. All right, coefficient. First one is coefficient. You guys recall what a coefficient is? Yes? No? Yes? How about as an example right here? If I have an example, say maybe 2x, what's the coefficient in 2x? 2. Okay, so it's the value in front of a variable. Yep, so let's write that in. It's a value. It's a value in front. Oops. It's a value in front of a variable. Value in front of a variable right there. Okay, so in the example 2x, what's my coefficient again, kiddos? 2. Okay. I'm going to go back up to the goals once you have that written down. I think I'm going to add one more goal to this today. I'm going to add one more goal to this today. Your job is going to be to get one variable in both equations to have the same coefficient. In other words, if there's a 2x up top, you're going to want maybe a 2x in the bottom. All right? So I'm going to add this up here. I'll leave this up here so you can see. But I think another thing to add right here for goals would be to try to have common coefficients in both equations. And I'll show you what that means here in a second. Try to have common coefficients in both equations. All right, so kind of more vocab that I'm going to turn back to. It's really a process instead of vocab, but another process I want to look at here is what adding equations to eliminate variables means. And we're going to use that process to solve these systems here. So here's an example of adding equations to eliminate variables. I'm just going to say this right here. Suppose you have something like 3x plus 4y equals, I don't know, 8. And maybe you have negative 3x plus 2y equals, I don't know, 4. First things first, is that a system? Okay, what makes that a system again? 2 equations with 2 unknowns, right? 2 equations with 2 unknowns. So, secondly then, we're talking about this idea of adding equations to eliminate variables. Now guys, as I take a look at those 2 equations, specifically the variables x and y. Is there a certain variable that has maybe something like close to the same coefficient in it? Which one, Nolan? Okay, so the x's. Now here's the deal. What's the coefficient for this x in the top equation? 3. What's the coefficient for this x in the bottom? -3. All right, here's what I want you to keep straight today. It's okay if the signs are opposite. So in this case right here, you have a 3x and a -3x. That's good. If you see something with a 3 and a 3 in it, they can be the same sign or they can be different signs today. Here's what's happening. Are the signs in that first example, if they're the same or different for the coefficient on the x? Signs the same or different for the coefficient on the x? There's actually one is positive and one is what? One's negative, okay? If you ever have to add equations to eliminate variables right here, you want common coefficients right here where the signs are different. So here's what I'm getting at. What would you have to do with 3x and -3x to combine them to make them go away or disappear, or in your word, you use cancel out? Would you take 3x minus -3x, or would you take 3x plus a -3x to make that cancel? You would have to add. So here's the deal. Adding equations to eliminate variables occurs when we have common coefficients in both signs where the signs are not the same, but one was positive and one was negative. Okay? What I'm going to choose to do is add both of those equations together. Let me show you why I can do this. Let me show you why I can do this. You have a $5 bill plus, I don't know, a $1 bill, which is equal to how much money, kiddos? How much money is that equal to? $6, okay? Suppose you have, I don't know, a $10 bill over here plus a $5 bill. What's that equal to? $15. All right, over here on the left, if I would add all this stuff up here, you have how many 5s, guys? 2, you have a 1 and a 10. You have a 1, you have a 5, you have another 5, and you have a 10. What's this add up to on the left? If I would say that's equal to this over here, 6 and 15, when I add those up, what's this equal to? 21. So if I take what's on the left and add those two together to form one line, and take the two on the right and add those together and form the right side, isn't that still a true statement right here? You told me the left was 21, the right was 21. So back here on this example right here, say, okay, how do you add equations to eliminate a variable? Well, since your signs are opposite on the 3x, because the 3x's are very much the same, we're going to add this all together. So here we go. I'm going to put a plus sign here in all of this. So the equation is 3x plus 4y equals 8. And to that, we're going to add a -3x plus 2y equal to 4. Okay. The parts that are important for us are the 3x's because those are values where the coefficient is 3 in front. Doesn't matter if the signs are the same or different. Let's add these up. If I would choose to add these two together, guys, what's 3x plus -3x? What's 3x plus a -3x? Cancels, doesn't it? Okay. Then my next row I can combine 4y plus would be what? 6y. This becomes 6y equals, what's 8 plus 4 on the right? By adding these together, which variable disappeared? The x's, leaving you with 6y equals 12. Would you be able to solve this now for y? You would, wouldn't you? Couldn't you just take 12 and divide it by 6? 12 divided by 6, and you would have a y value of what? 2. Once you knew y was 2, couldn't you plug that back in somewhere to solve for x? You could. Okay.
So if you're looking for something where the variables are kind of the same, or in other words, have the same coefficient, if the coefficients look the same, but one sign is positive and one sign is negative, what do you have to do with the two equations when the signs are opposite? Add them together. So what do you think is going to be the key down here if I wanted to subtract them? Instead of having opposite signs, you probably want the same sign. So let's write an example for this. Let's write an example for this. In this case right here, you would want same signs. All right, so here's an example of a system where you have coefficients that are exactly the same with the same sign. So let's see. Boom this up here quick. Whoa, wrong way, Parson. There we go. Oh, man. I'm getting too old, Mrs. Olson. All right, no comment. No sympathy for Parson this one. I get it. Okay. Guys, in that system right there, 4x plus 2y equals 16, 8x plus 2y is equal to 8. Take a look at your variables, x and y. Specifically, any one of those variables have the same coefficient. The y's are, okay? Now the question becomes this. Look at your 2y here and your 2y here. What kind of a sign do you have directly preceding the 2y? Addition. What else is preceding 2y in the second equation? So the question becomes, are those signs to those coefficients that we're really concerned about the same, or are they different?
They're the same.
The same, aren't they? They're both positive right there. So the question becomes, to eliminate one of the variables in the system of equations, do I add the equations together, or do I subtract the bottom one from the top one? Well, what's it tell you to do here? Subtract. So let's do that. Let's do that. Let's subtract this. I'm just going to put a minus sign right out here then. And the reason we're subtracting is the same sign. So what's 4x minus an 8x going to get you, kiddos? Negative 4x. Let's see. 2y minus another 2y. Cancels, right? And then on the right side, how about the 16 minus 8? 16 minus my 8 would be 8. Guys, by subtracting those two equations, you've rewritten a new one where negative 4x is equal to 8. Can you solve for x now? Can you solve for x? You can. Okay. So the big idea today is this. You're looking for variables with common coefficients. Doesn't matter if the sign is the same or different. You've got rules to figure out what to do here if the signs are the same or if they're different. And you're going to combine the two equations into one, solve for one variable. I'll show you how to get that second one. All right? So taking a look at example 1, let's see how this works. Taking a look at example 1. It says to do solve by what, guys? Adding. All right. Quick question. Explain to me why in this system right here we're going to use elimination, but we're going to add the two together. Why am I adding the two equations together? Okay, so specifically, are you looking at the x's or the y's, kids? Am I looking? All right, the x's. The x's both have which coefficient in front of them? 2. Are the signs for the 2's the same or are they different? They're different. So since they're different, or opposite if you will, what's your rule say to do up here? Add them together. So let's do that. We're going to add these. So I'm going to come down here. I'm going to put a plus sign right here and say we have to add these together. Reason being, the two x's that are common right here, kiddos, the two x's that are common right here, signs the same or different? Different. Okay, help me out. Negative 2x plus a 2x. What is it? They cancel. It's gone, right? All right, how about the positive 3y? That is a positive 3y, isn't it? Plus a negative 1y. What's 3y plus negative 1y when you add those? Anybody?
This becomes 2y when I add these, doesn't it? Right down here, this row right here becomes 2y. All agree? Agree? How about the last part of this then, after you bring your equal sign down? 4 plus -8, which is what? You know, -4, isn't it? All right, question, guys. When I add the two equations together, we have one equation with one variable. Can you solve for that y value now? What is it? Yeah, when you divide by 2, y is what value? Did you say -2? All right, so I know y is -2. So now that means we need to solve for what, kids? What do you need to solve for now? You've got to solve for x now, okay? So now, what I'm going to do is this. I'm going to choose my first equation right here. And then I'm going to come back to this first equation. And anywhere where I see a y value in that first equation, what am I going to replace it with? -2. So let's do that in the second step. So in my second step here, I'm just going to use the top equation, which says -2x plus, what's it say, 3y equals 4. All right, gang, help me out. What do you want to do right there? What do you want to do right here? Yep, so right here, we know y is -2, so come back into the y value and plug in what? -2, so this becomes the following, -2x plus 3 times -2 to equal 4. See? So all I've done is taken that y value of -2 and put it in right there. All right, how about this right here then? 3 times -2, what is that, gang? -6. So if you guys agree, now you have -2x minus 6 equals 4. Everybody agree? Okay. Now what? Jacob? Add 6, good. So you've got -2x is 10. So then you'll divide by -2. Which would be how much? -5. Guys agree -5 for my x? So I'll move that up to here when you divide. X is equal to -5. Now again, I know that Big Ideas is going to say, hey, let's finally express our answer as an ordered pair. So based on our solution right here, what are you going to have? -5, comma, -2. That's going to be the solution that you want right here. Okay? -5, comma, -2 is what you want. Substitution by elimination. Look for a coefficient that has the same value, regardless of sign. Once you figure out if the signs are the same or different, that'll determine if you add or if you subtract systems. Okay with that? All right, so I'm going to have you guys kind of try one on your own here in example 2. See how far you get. I think you can do it. I guess I'm going to ask some questions. By the way, everybody have that down right there? Anybody need more time with that page? All right, we're either adding the equations together or subtracting. And then we'll look at a unique case where adding or subtracting doesn't just happen right off the bat. All right, so this already says an example of solving by what, kiddos? Subtracting. Okay? Subtracting. Why am I subtracting this thing? If I look at my 3x's, which are the same, on the 3x's, are the signs for the 3x's the same or are they opposite?
the same. So to make them go away, you have to do what with both? Well, got to subtract. So if I go 3x minus 3x, cancels, right? Now be careful on this. Be very careful on this. Next part is going to be 2y minus what type of a y? Subtracting a negative is the same as adding. So this is really 2y plus what? To get equals. So we're subtracting, right? Okay, so 4 minus 16, right? 4 minus 16. What was that again, Jacob, for a value? Negative 12. All right. So that first step really determines if you've got a value or not. Can I get a value for y this time now? Can I get a y value? What is it? Perfect. All right, how about a volunteer to tell me what to do after that now? Want to use the first one or second one? I always use the first one and stuff like this. I just grab the first one and say, okay, let's use the first one. So I'm going to call this 3x plus 2 times what now? Two times negative 2. Set that equal to what value, kiddos? Okay. So this is now 3x. Whoops. 3x minus 4, isn't it? It's not working very well today. All right. So 3x equals 8. Let's see, is 3 going to divide evenly into 8? It'll be kind of ugly, isn't it? So let's just leave that as a fraction. Call it what over what here, Joe or Jacob? Other way around. 8 over 3. Hey, can 8 over 3 be reduced at all? No. No. Can't be, can it? Can't be, can it? So your solution would be what comma what this time? (8/3, negative 2. Very good. 8/3, negative 2. There it is. There it is. Now guys, this stuff works really well when what? What's happening for us? What's been true about the coefficients that we've looked at? They've been the same. Is that how it's going to happen? No, it's not. Take a look at example 3. Oh my gosh. Oh geez. Oh gosh. What are we going to do here? Let's see, I have a 3x and a negative 6x. So can I use those right off the bat? I have a 2y and a negative 5y. Those match in any way, shape, or form? No. Oh boy. Oh boy. Can we even solve this thing? We can. Anybody have an idea? All right, here's the deal. First of all, example 3 says solving by doing what? Rewriting coefficients. Right? I want you guys to make a note right here in example 3. If you ever have to rewrite stuff, meaning that there's no same coefficient, I like to do what's called a, whoa, that's pretty bold. I like to do what's called a crossing method. Okay, now the cross method, I'm going to go ahead and do this right here. I'm always going to say use positives. You're going to cross with positives. Crossing with positives, I'm going to say that because u If you start doing stuff with negatives, there's a chance you may forget to flip a sign. I don't want you to do that. So if I do this cross method with positives, it ensures that you won't ever have to change the sign. Okay? So here's the deal. I look at the first two that match up. The way this is written, x is written before y, isn't it? Okay, look at your first value right here, 3x. What's the coefficient to 3x? 3. I'm just going to put a 3 down here in parentheses like this. Now look at the other x right here. What's the coefficient there? It's -6. But I'm only going to use what type of values? Positive. So I'm going to throw a 6 up here. Guys, we've talked an awful lot about equations. If I do one thing to the left and the same thing to the right, are you ever changing it? No. So what I'm going to say up here is this. The 6 is up here for the purpose of saying multiply everything up here by 6. Let's do that, and I'll show you why this is doing it the way we are. So we're going to rewrite this thing. The first part, do you understand my crisscross method, by the way? Look at the 3 here in front of the x. Bring the, I'll show you why here in a minute. Okay. The reason we're doing this right off the bat here, though, Tori, is do any of the x's or any of the y's match with the same coefficient? They don't. So this is why we have to do it in the first place. Okay. Watch what happens here, guys. If I multiply everything by 6 up here, what's 3x times 6? 18x, right? If I take the 2y times the 6, what do I have? So plus 12y. And if I take the -2 times the 6 on the right, what do you have? All right, great. Now, do the bottom equation by 3. Now, all I've done is take these leading values, crisscross them out here, and we're going to say we're going to multiply everything up top by 6, multiply everything on the bottom by 3. What's 3 times -6, guys? Anything jump out at you in that first multiplication right there? What's true about the x's now? They have 18s in front of them. Is that good or is that bad? That's good. That's what we've tried to establish here. So if we don't have what we need right away, we go ahead and rewrite it so that we can obtain what we need. We've got to take everything times 3, so a -5y times 3 would be how much? -15y, right? Been a long week, hasn't it, Emily? And then how about the 3 times the 2 on the end? How about the 3 times the 2 on the end? 6. All right, so take a look at this right here. Now, after rewriting this right here, don't you have 18x's? Oh my gosh, I don't want to do that. This is not working very well today. What do you notice right here? They are the opposite. The 18x's are the opposite. So adding or subtracting these two? Add them. Add them. Here's how I remember. Same, subtract. Same, subtract. S and S. That's how I remember. Opposite, add. Opposite, add. O and A, vowels. Okay? What's 18x plus a -18x going to do? That's just gone, isn't it? Okay, how about this middle column? 12y, positive 12y plus -15y. What is that? Anybody? 12 plus -15 would be -3y, wouldn't it? And then help me out here. -12 plus 6 would be -6 right there. What's the y value?
2.
Y value is 2. Y value is 2 when you divide by -3. Well, once you know y is 2, I'm going right back up to my original first equation. My original equation. What's my y value again?
2.
All right. So I'm going to write this just exactly as is, but I'm going to replace the y value right here with 2. So this top equation originally was 3x plus 2y. Now 2 times 2 to equal
What value? -2. Squeeze that in there, get in there. All right, this is 3x plus 4. Agreed?
Yeah.
Back to 4. So I have 3x equals -6. What's that make the x value, kiddos? After subtracting 4. So in ordered pair form, how do you want to express this? -2 comma 2. Right? So the idea, look for common coefficients. If you don't have common coefficients, what method do I want you to use? With what types of values? Positive, so it ensures that you don't have to change any signs in here. Once you've got the system rewritten, you got to determine if you're adding or subtracting. So I want you to try one of these on your own, so give me a second here. Let's squeeze this in here a little bit. I wanted it to. That was a big time failure. All right, you guys try this one right here. You guys try this one. I'll try and make this as easy as possible on you. Let's go 2x plus 4y equals 18. Let's go 3x minus 2y equals -5. Okay, I want you to try that on your own right there. Anything that matches up right away at all. X's match, the Y's match. No, so are we gonna have to crisscross in this one and rewrite, or can we just start with it? 54. Let me ask a question here. What are you gonna multiply the top by? What are you gonna multiply everything in the top by? 3? What are you gonna multiply everything in the bottom by? 2. Okay, so take a minute and give that a shot. Once you've got an answer, check with a neighbor. See if you agree. If you disagree, talk about why you disagree. If you get stuck, see if your table partner can help you out. Times 5 is 90. Suppose I better do this problem, huh? 6, so hopefully it works out nicely. Does it? Story is the Y value. Is the X value. Okay, I want to make sure I get through all this today since we do have advisory.
first question. Any x's or y's have the same coefficient regardless of sign in front of it? No. So this is where crisscross comes into play. If you're old school like me, crisscross is going to make you. All right. What am I multiplying the top by? 3. Everybody multiply that by 3. How about the bottom? 2. Now, guys, I'm going to tell you this right here. I could have multiplied everything up here by 2 and everything down here by 4 if I wanted to. If I wasn't wanting to work with the x's, I could work with y's that way too. Makes sense? Okay. All right, so what's the top get rewritten as? 6x plus 12y equals 54. What's the bottom get written as? Plus 4y or minus 4y? Minus 4y. Everybody agree? Top times 3, bottom times 2. And you'll know that you're on the right track right there after that step, because after that first step, what's true about your 6 x's? What's true about your 6 x's? They're going to cancel. Addition-wise or subtraction-wise now? Subtraction. Signs are the same, so we have to subtract. All right, so be careful on this subtraction. This is where people get stuck. I'm going to go a positive 12y minus a negative 4y. Subtracting a negative is really adding in that column. So here we go. This becomes 16y. How about 54 minus a negative 10? What's that value? 64. Good. And 64 divided by 16 now is? 64 divided by 16 is? 4. Good, CJ. Good. Divided by 16, you've got y equals 4. All right. This isn't that bad, is it? Not that bad. All right, so I'll move over to here. I'm going back to my top original equation. Top original equation, 2x plus 4y. What do you want to replace the y with now? What do you want to replace? What are you going to replace y? 4. So top equation, 2x plus 4 times what? 4. Can I just do the 4 times 4 in my head now? Okay, so I'm going to write this top one as 2x plus what? How much? 16, good. All right, so this becomes 2x equals 2. What's your x value here? 1. All right, so I'm going to write this as an ordered pair. It'll be 1, comma, 4. One comma 4. How many have 1 comma 4 there? Okay with it? All right. Let me know when you've got that all down. I think most of you have it down. You can show hands. How many are okay with this right now? Feeling okay about it? Good. Good, good, good. You guys must have had a long week. You're all quiet this morning. Long week? All right. Anybody need more time with that page? All right, one more problem here quickly, and I'll get you going for the rest of the week, okay? All right, kiddos, how about a volunteer to read this real-life example for me? Who would volunteer to do that for me? Go ahead, KB.
Location 5 receives 3 large trucks and 2 small trucks for a cost of $275. Location B receives 4 large trucks and 3 small trucks for $375. What is the cost of each truck?
So we need to find the cost of a large truck and the cost of a small truck. You guys are going to help me set this up. Okay? What are we trying to find the cost of? Small truck and large truck. So how many unknowns do I really have here? 2, right? What do you want to assign your unknowns to be? Which variables do you want to pick? Let x and y. Okay. Let x equal, oh boy, I do that all the time. Let x equal what? You want x to be the number of small trucks or the number of large trucks? Number of large trucks. Okay. Well, if you've assigned x to be the number of large trucks, what are you going to assign y to equal? All right. Underline this right here. Location A receives 3 large trucks, 2 small trucks for a cost of $270,000. How about a volunteer to help me write an equation for the first part of the system for location A? 3x. You said equals 270,000. Okay, let me write this down, Tori, and you tell me why you wrote that first equation the way you did.
Because there's 3 large trucks and 2 small trucks.
So 3. Okay, so I've got this written wrong right up here, guys. I'm going to go back and reassign my x and y. Instead of saying number of large trucks, this should not say number of large trucks and number of small trucks, but rather, what were we trying to find, guys? The cost. Okay, so this should be x equal my mistake right there. The cost of large trucks and cost of small trucks, because they already tell us how many we have, right? Right? Okay, so let me clean that up there quickly. First mistake I made all year, right, Jacob? That I can remember anything, right? Okay. Everybody agree with that first equation? All right, so there's 3 trucks at a cost of x dollars, 3 large trucks, cost of x dollars, plus 2 small trucks at a cost of y dollars per truck. That has to total 270,000. All right, how about my next one? What's the second equation going to look like? 4x plus 3y equals, what was the value? 375,000? You guys agree with the system?
Yeah.
Okay. Can we proceed or do we have to crisscross? So what are you crossing up to the top here? 4. What are you crossing down to the bottom?
3.
Okay, so I'll help you rewrite this when I crisscross this stuff. All right, 4 times 3x would be 12x. 4 times 2y would be plus 8y. Oh, help me out. 4 times 270,000, is that 1,080,000? Okay. And the bottom one, when I crisscross, 3 times 4x would be 12x again, plus 9y. And 3 times 375,000. Is that 1,125,000? Testing myself today. How am I doing? Adding or subtracting, kiddos? Subtracting because the signs of the x's are the same. Okay, so I'll help with subtraction. 12x minus 12x is gone. 8y minus my 9y. Negative Negative 1y. Oh my gosh. Negative 45,000? Okay, so when I divide both sides by negative 1, what's the y value there? So I have a y value of 45,000. What's your y representing? Cost of big or small? What do we assign? Y is the cost of a small truck, right? Oofda. If a small truck's 45,000, big truck might be worth more. Okay? Hey, check it out right up here. Isn't this my first equation original up here? What are you going to plug in for the y value right there now? 45,000. So let's do that quickly. I'm going to go 3x plus 2 times 45,000. This should equal 270,000. All right. When I multiply 2 times 45,000, you have 3x plus 90,000 equals 270,000. What do you have to subtract? So when I do that, I've got 3x equal 180,000. It's 180,000 divided 3, kiddos. 60,000. So when x is equal to 60,000, what's the cost of a big truck? Cost of a little truck is 45,000. Okay. All right. Lots of stuff going on there. Okay. Went a little longer than I wanted to, so I apologize for that. But just know that that quick quiz, if you want to correct it, I know it's the last thing that goes on your grade, but you've got until really Monday to get that corrected, okay? And try and get 5.2 done for me today.